All right, for slide 13, we have a person walks a certain distance to the east, and then they walk another distance, but this time at an angle, and they give us the angle north of east. So it'll be in quadrant 1. So the first thing we want to do is translate those directions. 44 meters east, that would translate into 44 meters at 0 degrees, because east is right on the 0 degree mark, the x-axis. 32 meters northeast, or north of east, 39 degrees, that would translate into just 32 meters at 39 degrees. So those are our vectors. It has magnitude, it has direction, and in order to be able to add those, we have to make sure that we break it down into its components. So each vector, we can think of it like a triangle. It has a certain length for its hypotenuse, and that's what we have for the second vector. And then it's going to have an x component, it's going to have a y component. Now, our first vector, you'll notice that it's purely horizontal. So when we do the calculations, we're only going to end up with an answer on the x-axis. So, since we're dealing with triangles and angles, we're going to have to do SOHCAHTOA. We're going to have to do a little bit of trig, but it's not too bad. Anytime we're trying to find the x component, we're going to take our vector and multiply by the cosine of the angle. So for the first vector, 44 cosine of 0 gives us just 44, because it's purely horizontal. 44 sine of 0 would give us 0. So anytime we're looking for the vertical, the up and down component, we'll use the sine of the angle. Our second vector, this is the one that's going to give us some numbers. And the second vector, it's in quadrant 1. So it has a little bit on the x-axis, it has a little bit on the y-axis. So we'll plug in 32 cosine of 39 degrees, and that gives us 24.87. 32 sine of 39 degrees, and that gives us 20.14. Again, this makes sense. Our angle is at 39 degrees, so it's a low angle, a shallow angle, and it has more horizontal than it has vertical, just like what we have drawn here. All right, so once we have both components, now I know how much of each vector is on the x-axis and how much is on the y-axis, and what we're going to do now is just add those. So on the x-axis, we have 44, and we have 24.87. So the total on the x is 68.87. 68.87. The total on the y-axis is going to be 0 plus 20.14. And that's just going to give us 20.14. Now, these represent the two sides of our new triangle. These are the two sides of our new triangle. Our new triangle has a horizontal base, and that base is 68.87. It has a vertical of 20.14. And the answer that we're trying to work to and get to is what is going to be the result of adding these two. So, a lot of practice doing this before. You know to find the results of the two components is just to find the hypotenuse. So you have your side A, you have your side B, and we'll just do our calculation. And that's going to give us 71.75. Again, to do that, you're doing Pythagorean. 71.75. And that would be our final answer in meters.